Alright, so today we're going to talk about Chapter 2.2, which is all about physical properties. And a physical property is any characteristic of a material that can be observed or measured without changing the composition. Examples are things like viscosity, conductivity, malleability, hardness, melting point, boiling point, and density. So let's talk a little bit more about each of these things. So viscosity is a liquid's resistance to flow. An example of a high viscosity liquid is honey. And as you can see over in this picture here, as the honey is being poured out of the beaker, it really doesn't want to flow over itself. It comes out very slowly and kind of clumped together. So that's high viscosity. An example of low viscosity is vinegar. So over in this beaker, this is probably water, but vinegar is also a low viscosity, and it has no problem flowing over itself right out of the beaker. Now, viscosity is an interesting physical property because it can actually be changed with temperature. As you increase the temperature in a liquid, the viscosity usually decreases and it flows more easily. That doesn't always happen with physical properties. Conductivity is a material's ability to allow heat to flow. So an example of high conductivity is gold. If you heat up a piece of gold, it will release that heat very quickly and cool off very fast. And that's because it has a high conductivity. An example of low conductivity is wood. If you heat up a piece of wood, say in a fire, it will hold in that heat and it won't let it flow out very easily, and it will stay hot for a long time. And that's because it has a low conductivity of heat. Malleability is the ability of a solid to be hammered without shattering. This is why gold is such a great metal to make jewelry out of, because it has a good malleability, meaning it can be hammered and pulled and stretched into different shapes. You don't have to turn it into a liquid and re-freeze it into a solid to get it to take on a different shape. You can form it to different things. Now, glass is exactly the opposite. It has very poor malleability, meaning if you try and hammer it into a different shape while it's a solid, it's just going to shatter into 1,000 little pieces. So it has a poor malleability. Hardness is literally how hard a material is. It can be measured by looking at what materials can scratch the other. So an example of a soft material is wood. We think of wood as being pretty hard, but it turns out there are some woods that can be scratched by our fingernails, and almost all wood can be scratched by a nail or a rock. So it's very easy to mark the wood with a different material, meaning that it's pretty soft as far as solids go. On the other hand, diamond is a hard material. It's the hardest material that we know of. So as of right now, diamond will scratch everything, but nothing will scratch diamond, and that's because of its hardness. Melting and boiling points, I'm sure you've heard of, are the temperatures at which a solid becomes a liquid and a liquid becomes a gas, respectively. So an example of a very low melting point is nitrogen. You have to get nitrogen super, 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 super cold to get it anywhere near becoming a solid, going from the liquid to the solid state, which is what we call the melting point. On the other end of the spectrum, gold has a high melting point. We have to get it really, really hot before it will start to turn from a solid into a liquid. Now in this picture, you can see an example of something that has a very medium melting point. And this is the metal element gallium. And gallium, it turns out, has a melting point at about room temperature. A little above room temperature. So when you hold a piece of gallium in your hand, it will start to melt in your hand because its melting point is even below the temperature of your hand. So you are turning it from a solid into a liquid, which is actually really cool. And finally, density is the compactness of a substance. And we've talked about density quite a bit. It's the mass per unit volume of an object, or literally how much matter is in a certain space. Now, an example of a really dense substance is mercury. Mercury is about 50 times more dense than water. So that means if you have about a cup of mercury, it's going to weigh over 20 pounds, which is really crazy to think about because it's really not that much space it's taking up, but it turns out there's a lot of stuff in that space. There is a lot of matter in that space, which is what makes it so dense. Now, physical properties are important because we use them to identify materials or choose material for a specific purpose. An example of this is density. So if you have an unknown solid, you can put it on a scale and measure its mass and then find its volume and calculate its density. And once you've calculated that density, you can compare it to the known densities of different materials and see what it's close to. And that will help you identify what kind of material that is. There's actually a scientific story that goes along with this, and it has to do with this crazy guy in the bathtub here. And this guy's name was Archimedes. So in Archimedes' time, there was a king, and he had a crown. And the crown maker told him, this is solid gold. It's pure gold, and it is the most expensive crown I could make. But the king wasn't so sure. He suspected that the crown maker melted some kind of different metal in with the gold to dilute it, so he wouldn't have to spend as much money. And the king tasked Archimedes with finding out if the crown was real gold or not. And Archimedes knew the density of gold. So he thought, well, if I can figure out the density of this crown, and it's similar to the density of real gold, then I know that it's made out of real gold. But how do I find the density? It's easy to find the mass of the crown because you just put it on a scale. But it was really hard to find the volume of the crown because it was such a weird shape. And the story goes that Archimedes was sitting in the bathtub one night and he realized as he sat down in the water level rose around him. And he realized the water level rose the same amount of his volume that was in the water. He figured out what we call water displacement to figure out the volume of an object. And you guys all did this on your test last week. When you put the rock inside the water, it went from one volume to another, and the difference in those volumes is the volume of the rock. So Archimedes was able to figure out the volume of the crown by submerging it in water, and therefore he was able to calculate the density and figure out if the crown was real gold. And the story goes that he was so excited about figuring this out, he jumped out of the bathtub immediately and ran down the street yelling, "Eureka!" all naked and everything. I don't know how true that is, but that's how the story goes. Now, physical properties, as we know, can also be used to separate the substances in a mixture. So we did this in the separating mixtures lab that we did earlier in the week. Some methods of doing this are filtration, which takes advantage of particle size, and distillation, which takes advantage of boiling points. So in the separation of mixtures lab, you used the fact that sand has bigger particles than salt water to separate the sand from the salt water using filter paper. You also used the different boiling points of salt and water to separate the water from the salt by evaporating the water off and leaving the salt in the bottom of the beaker. You also used the physical property of solubility to separate the dyes in the felt pens when you did the chromatography lab. And those are all based on really important physical properties of those substances. Now we're going to talk more about physical properties in the next few chapters when we talk about physical changes and chemical changes. And these will become important.